This is the data centers in space race, and it's accelerating faster than almost anyone expected. In November 2025, a 60-kilogram satellite called Starcloud 1 separated from a SpaceX Falcon 9 and powered up an Nvidia H100 GPU in low Earth orbit. It was the first time a modern data center class AI chip had ever operated in space. Within weeks, it had trained a small language model in orbit and was running a version of Google's Gemma model from 350 kilometers up. 5 months later, the FCC had 3 competing proposals on its desk. SpaceX wants to launch up to a 1 million orbital data center satellites. Blue Origin's Project Sunrise calls for 51,000. Starcloud, the Nvidia-backed startup that flew Starcloud 1, has filed for 88,000. And then there's Google, which announced Project Suncatcher with prototype satellites scheduled for early 2027. The driver is AI, and specifically the energy and infrastructure problem AI has created on the ground. Global data centers used roughly 415 terawatt hours of electricity in 2024, about 1.5% of world's consumption. The International Energy Agency projects that will double to around 945 terawatt hours by 2030, comparable to Japan's entire electricity demand. Goldman Sachs has projected even higher numbers, around 1,350 terawatt hours. A single AI-focused hyperscale facility now draws between 100 and 300 megawatts continuously, about 10 times what a conventional data center pulled a decade ago. The grid cannot keep up. On top of that, terrestrial data centers consume enormous quantities of fresh water for evaporating cooling, occupy large amounts of land, and increasingly run into community opposition and permitting delays. Space, in principle, removes all four constraints at once. The main companies in the race break into 3 groups. The first is rocket and constellation operators. SpaceX wants its orbital data centers to ride on Starship and connect through Starlink's optical mesh. Blue Origin's Project Sunrise is paired with a separate 5,408 satellite communications constellation called TerraWave. Both companies have a vertical integration advantage. They own the launch vehicles and want to keep the launch revenue inside the company. The second one is the dedicated startups. Starcloud is the furthest along. Starcloud is partnering with Crusoe to offer commercial GPU time from orbit starting in 2027. The third is the hyperscalers and adjacent players. Google's Project Suncatcher will fly 2 prototype TPU satellites with Planet Labs in early 2027. Here's why data centers in space are closer than we think. Starcloud 1 has already demonstrated that a terrestrial data center class GPU can survive launch, vacuum, and radiation while running real workloads. Free space optical links between satellites have now been tested at speeds above 1 terabyte per second, which is what makes a distributed orbital data center technically conceivable. The economics depend on launch costs, and SpaceX reusable Starship is projected to bring per kilogram launch costs into the $10 to $150 range. Starcloud's CEO has said his company becomes cost competitive with terrestrial data centers when launch lands around $500 per kilogram, well above Starship's target. Here's a realistic timeline. Independent researchers are consistent on one point: full-scale operational data centers in space are not arriving in the next 2 or 3 years. What is arriving is a sequence of progressively larger demonstrators. Starcloud 2 in late 2026, Google's TPU prototypes in early 2027, Starcloud's first commercial GPU services from orbit in 2027. Bezos has said gigawatt-scale orbital data centers are realistic in a 10-plus year horizon. Whether the endpoint is a million satellite SpaceX constellation, a 51,000 satellite Blue Origin one, or something in between, the underlying claim now has working hardware behind it. AI compute can run in orbit, and the bottleneck driving it off the planet is real.